All right, welcome back. So we're gonna try finding the derivative of this function, and in fact, they're asking us to find the derivative, the second derivative. So of course, we have to do this twice. So let's begin. Let's take the first derivative. Now, if you notice here, we could do this in two different ways. We could distribute this here, right? But this will require us for us to do a lot of product rule. So instead of doing that, let's just keep it as it is. I think this is much better because all we have to do is use product rule. Let me maybe highlight this. So this is one function, and then this is the other function, right? So we have a product of two functions. So when we have the product of two functions, then we use the product rule. So let's go ahead and try that. So the derivative of the first one times the second one. Oops. And then plus the first one times the derivative of the second one. Right? And then now let's go ahead and execute it. The derivative of this tells us that it's going to be itself times, because we have a function in the exponent, right? We have to apply the chain rule, so we're going to multiply this by the derivative of the inside, right? Well, what's the derivative of 3 to the x? Is going to be 3, right? This one stays the same, right? And then here, this one stays the same. And the derivative of this will be the derivative of negative 3 is 0. The derivative of negative 3x is negative 3. And the derivative of negative 2x squared is negative 2 times 2x to the 2 minus 1. So basically what we have is negative minus 3 minus 4x. Now we have to find, this is the first derivative, but now we have to find the second derivative. If you notice here, we would have to do the product rule again for this, product rule for that, and then also the product rule for that. That means we have to work twice as hard, right? Well, what about if we actually consolidate this, right? What about we just use some algebra? Let's use some algebra and simplify this. And what I mean by that is they both have a common factor of e to the 3x. So if we factor that out, then what's left behind? And what we can do here is we're going to factor out this and this. So those are going to be gone. So we can use this to expand this or distribute that. And we can do this in the next line, right? 3 times negative 3 is negative 9. 3 times negative 3x is negative 9x. 3 times negative 2x squared is negative 6x squared. And then plus, well, this is gone, and now we have negative 3 minus negative 4x. We can drop the parentheses because there's nothing in front of them anymore. And I just added an extra x there. There you go. All right, we can simplify this, and this will give us e to the 3x. And simplify this, give us minus 9 minus 3, that gives us negative 12. Minus 9x minus 4x gives us negative 13x. And then minus 6x squared. Okay. And then let me check my notes. It looks good. Let's see. Yep. All right. So this is the first derivative. Now let's find the second derivative. But now, if you notice, we only have to do one product rule, right? So from here to here was, from here to here, everything from here to here was algebra, right? And so let's go ahead and do the derivative. If you guys are seeing this, this is one function and this is another function. So when you're multiplying two functions, we have to use the product rule, right? And then if you guys can see that, that's going to be u v, as we've done before, u prime v plus u times v prime, right? So therefore, what we're going to do here is we're going to take the derivative of the first one, leave the second one as it is, and then plus, leave the first one as it is, and multiply by the derivative of the second one. All right, and so we'll do that, and this will give us the derivative of e to the 3x is itself. But because there's a function in the power, we have to multiply using chain rule, multiply by the derivative of the inside. Right? The derivative of 3x is going to be 3. All right, leave this one as it is. And this one is just e to 3x. And the derivative of negative 12 is 0. The derivative of negative 13x is negative 13. And the derivative of negative 6x squared is negative 6 times 2 times x 2 minus 1, right? Using power rule. Right, write down the power and multiply by negative 6. It gives us negative 12. So there you go. So this is technically the derivative, but we want to write it. We want to simplify this a little more. We see here, and this is a very common process, right? This is not as is a common for us to actually factor the e to the 3x, right? Because they're both terms have the e to the 3x as a common factor. So we're gonna go ahead and factor it out, e to the 3x, and what's left behind. We'll do the same thing pretty much what we did before, which was distribute this, right? And then combine it with that. So it'll be negative 3 times negative 12 is negative 36. 3 times negative 13 is negative 39x. 3 times negative 6 is negative 18x squared. Minus 13 minus 12x, right? We just carry the other ones because we can drop the parentheses from here because this one is gone. And there's nothing in front of it, and that's just a plus. If there was a minus, then we would have to distribute the minus to those two. Let's go ahead and simplify this. So this is e to the 3x and negative 36 minus 13. Both are negative, so we combine those two, and that gives us negative 49. Negative 39x minus 12x gives us negative 51x, and then minus 18x squared. And we can probably factor that. You notice there's a negative in every factor, so we can factor it out, and that will give us this, right? And let me check my notes, and it looks good. All right. So this is the second derivative of x, right? And this is it, right? So we did the derivative here. That was the derivative right there. And then after that, we just use some algebra. We use the product rule